Gollob from BMW, who will introduce present on current trends and their impact on in-vehicle Ethernet architecture. So after working in suspension design for different projects, Christoph began testing vehicle dynamics ECUs for BMW in 2010. In 2012, he became test manager for these ECUs, then technical manager for driving dynamics and ADAS ECUs in 2021, Christoph moved into IVN Central Department to lead architectural discussions concerning IVN and became responsible for the pre-development program within IVN. Thank you. Christoph.
Thank you. The click thing is over there. Great. So, welcome. I'm glad to be here, and I hope I can give you an insight and a point of view you have probably not had yet, although I'm probably not telling you any new truths. And thank you to Thomas and Vlad before. They helped me a lot to tell how zonalization works, so I can go probably a little bit shorter over this. Start with what is an EE architecture. An EE architecture defines the partition of functionality over different ECUs and how the connection between these ECUs work. And we have to scale our architecture. It's a big thing, and we have to scale it for different, I would call it, scaling dimensions. You can build your architecture for a small car, like a Mini. You can also build your architecture for a luxury sedan, like a 7 Series. Or you can try to build one architecture to fit both of them, and then you have to put in the flexibility to stretch it. Next thing is, you can always implement a new architecture, just put it in your new cars, or you want to reintroduce this new architecture in your older model years too. So that is meant by this Neanderthalian guy and the youngster. And next scaling dimension, you have to scale for your different propulsion systems. You have a different EE architectural approach for a BEV car than for an internal combustion car. And lifecycle management is one part of it, since you don't have that big of a battery for, when you're standing around in an ICE car. And everything in between, hydrogen, plug-in hybrids, whatever. And a dimension always been there, but getting more and more prominent in the last few, I even can say days, is our fragmenting geopolitical regulations. So if you want to sell your car on one side of the planet and you want to sell it on the other side of the planet, probably you have to change parts of it, and you have to design your architecture to be capable of doing so. So in short, you have to, besides manufacturability and other stuff, you have to design your architecture in a way it works for all the scaling dimensions and all the scaling spread you want to do. And now look at the trends. Zonalization. Zonalization is definitely here to stay, and I'm pretty happy to the presentation before, so I don't have to tell you zonalization is coming from power. And its main benefit is coming from power, and having the ability to not route every cable to a centralized fuse box, and your customer is able to change the fuse if something is wrong, but to distribute power zones and hide them somewhere within the car and remote control those fuses is a big benefit. But we also want, and we also have started to put communication into this zonalization too. And if you go any further, like zonalizing audio or zonalizing fast control loops, we need a powerful Ethernet backbone. So it is impossible to zonalize anything like that if it's not on a powerful Ethernet backbone. So to see that this is already working pretty well, here is the picture of our 2021 model year. It's not old, a BMW i5. And you see the cabling within the car. This is our pre-zonalization wiring harness. And now you see a picture of the Neue Klasse architecture, the car you have seen on the IAA this year. Here it's in the shape of the coming 3 Series. You see the difference. You definitely see a difference, and this is mainly coming from power. Next trend. It's also a known issue. Former distinction factors are just becoming hygiene factors. Functionality trickles down. AC was something new several years ago or several decades ago. Now you don't sell any car without AC. Same is for level 2 driving assistance. Same is for IVI systems. And what do you need for having it there, and what do you need to stay relevant within your car is, first of all, updatability. You need over-the-air update, bug fixing and bringing features to your cars. And to be even able to bring features to your cars, you need a base layer security. You don't want to do your security analysis every time you bring a new feature. You want to have something as a baseline and not think about it when you bring it to the car. It's just there. Let me give you some details on this. So, with Neue Klasse, we brought MACsec as a base layer through the whole Ethernet network. We don't have to reconsider security within the Ethernet network, just functionalities which are probably really, really secure. You can always add something like IPsec, but just for them. We have SecOC for CAN and CANFD, and we are also starting with post-quantum cryptography-enabled key exchanges for non-diagnostic components. A big part here is cameras. We want to stay that cameras within the car, and we want, thinking about level 3 ADAS or even going further, we want nobody doing stuff with those cameras. Something to over-the-air. By the beginning of the year, we had more than 10 million over-the-air updatable cars within the field. We already brought more than 16.5 million updates, fixing more than 290 bugs or bringing features. And by doing so, we saved more than 130 million euros. Just to give you some numbers, why we saved it? If there is a bug, otherwise the customer would have come to the shop. And somebody would have to do work, and somebody would have to pay him, normally us. Next trend, geopolitical challenges. I already told you, it's a big mess, and the mess is increasing, and regulations are, the timeline regulations change is also more and more short. So how can we handle this? Standards. We are all here because we like standards, and standards are really helping us here. And here, short history about BMW and standards. We are definitely eager to push standards. And Kirsten yesterday in her keynote told we were pushing Ethernet into the car by having it a standard and having a multi-vendor environment. And you see a lot of standards here where BMW is pushing and being on the forefront. And why are we doing it? Because we think we can bring a system-level understanding to the table. We can tell what is the problem on a vehicle level, and with the discussion with our supply chain, we can find the right solutions in a standard and pioneer them together. It was a good business model the last decades, I would say. And what else? Why do we want standards? Standards increase our geopolitical resilience by having a worldwide supply. You can buy Ethernet components from American companies, you can buy Ethernet components from European-based companies, and you can buy Ethernet components from Asian-based companies. And it's the same for CAN, and it's the same for ASA Motion Link already. It's not a BMW presentation without mentioning ASA. Yeah, and why do we also push for standards? Because we see having all these standards there lead to competitive products, competitive prices for these products, and we are not in a vendor lock-in, which is not nice if you're relying on some parts coming from one side of the world and you can't ship them to the other side of the world. So pushing this standardized ecosystem together helps us all. Okay, the obvious trend, AI. AI is coming to the car. It is already there, and it's growing and growing. And to get AI into the car, or to make AI more usable in the car, we have to bring the data to one centralized point. It's the one HPC you're seeing on different slides all over again. And IP-based protocols help us to bring this data together and help us to bring this data to the backend. But it's not necessarily done only that way. How will this work together? There will be AI just working in the car. It is aware of ideally all the information available in the car, so it's centralized. It helps you in keeping the data privacy, so it's not telling anybody what's going on with you, what are you doing, if you don't want to send it away. It's quick. It works even if you have no backend connection. And if you drive a current car and try to do anything with speech control and it has no internet connection, it's not so a nice experience. Let's state it that way. Yeah, it's highly interconnected. And all the data you analyze within the car is concentrated there. You need less bandwidth to do any analyzation if it's pre-analyzed, if you want to do it in the backend. But on the other hand, backend will stay there. Backend has more computing power. In backend, you have all the fleet data. In backend, you learn, you do your learning experience, what the average customer is doing, what the fleet is doing. It's not such individualized, and we will have both agents working together. And now, as a state, I will not tell you anything new. Everybody knew about AI. But what is the consequence? If we want to put all the data to a centralized platform, to a centralized HPC, probably we don't have this high bandwidth backbones between different domains. We have to put the data together in one point, one single point of truth. Next trend, complexity reduction. Yeah, we are in a difficult world, and we have to react to difficult scenarios. Why make our life a mess by our own? So, what can we do? We at BMW try to unify our software. We are already going to AutoSAR. We're doing a lot in AutoSAR. We are pushing to minimize the way we approach different problems. We unify our solutions. We want to, and that's now again networking, we want to reduce the few scalable protocols. And here Ethernet is definitely a big role model. And we want to concentrate our functions. As Thomas just said, if I have a distributed system, I have to find the root cause. If I have a unified system, I still have to find the root cause, but I have more idea where to look. So, left side, communications protocols. Starting with the lower end. CAN is here to stay. CAN solves problems. CAN is easy. CAN will work. We are not kicking out CAN out of the car. It's definitely there to stay. There are use cases which work best in CAN. But we can learn from Ethernet. We can make it scalable. So already in our Neue Klasse, we brought the CAN-FD protocol down to 500 kilobit. And we know we can bring it easily up to 5 megabit. We just have no application yet for it. So you have a scalable CAN-FD. It's one protocol, and your software is written for the same protocol. Your messages are written for the same protocol. You have a scalable solution. Next, above this, starting from 10 megabit, you can use Ethernet, and we are using it from 10 megabit up to gigabit, even beyond. It's one protocol. You don't care where this software is heading to. It's a 10-base node, it's a gigabit node, it's the same frame format, it's the same way of approaching things, it's the same messages you send. You just have to look for your bandwidth. Above this, in our current generation, we have GMSL and APIX for the service solutions. We want to find, it's one of the last things we have to change, and again, I have to say, it's not a BMW presentation without ASA. We have decided to go ASA, and pretty new decision. Our displays have decided to go to ASA 2. And I give you the reason for this. All this layering of communications protocols are interwoven into each other. You can tunnel, and we started to tunnel CAN-FD via our backbone to the rear zonal module with AutoSAR usage. And ASA has a specified 100 meg side channel. We want to flash our next generation displays using Ethernet on exactly this ASA side channel. That's the reason why our displays changed. They wanted a multi-vendor market, they wanted to move forward, and They wanted something where they have exactly the side channel which everybody in the world is using. It's Ethernet for flashing components, if they are a little bigger than small kind module. Next thing, by having less of exactly this different fragmented protocols, we can reuse software more easily. We can have a learning curve and base on what we started. We can make software reuse and software growing evolution. So continuing our evolution and not reinventing the wheel every time again. So it's a little bit of a BMW trap. We always fall into it, but by creating a more stable platform, we can at least move in that direction. And that's what we definitely want to do and we have to do. You're here because you wanted to see how this architecture looks then. It's probably a slide you also know by heart. There is an HPC on the bottom controlling everything. There are zonal models doing the power distribution and parts of the data distribution. And there are a lot of periphericals. And to the question before, these periphericals, they will ever be increasing. It's the number of this bottom line. You can't control. It's like, it's more and more. On the middle column, you see, we already are more or less where we want to head. In our Neue Klasse architecture, we have 4 superbrands. We have an IVI superbrand, we have an ADAS superbrand. We have our heart of joy, because we at BMW believe in the joy of driving. And we have a body superbrain, which more or less also works as our zone front. So it's a combination of those both. It's a superbrain and a zone in one box. We have our zones. We have a roof zone. We have the rear zone, I already told you about. And we have a pure power distribution zone, just distributing power, not distributing any information. And below this, we have our peripherals. And we connect this with Ethernet, as I told you, 10 megabit up to gigabit. We have our high-speed CAN, CAN-FD. High-speed CAN we want to get rid of. We still have FlexRay, which is a good protocol, and they have good ideas. It's just why using more technologies than necessary. And we have our proprietary status. ASA was not ready yet. And we have MACsec as our base layer security. Where do we want to head? We are happy with our superbrains. Just make them probably less, but more intelligent. We are happy with having zones. They help us in scalability. The scalability issue I told you in the beginning of the presentation. And we go to a more simplified approach on how we transport data. We are pushing for RCP, TC18. We see this will help us a lot to create easier peripheral ECUs and centralize the complexity. We think 48 volt will come on the long run, and Ethernet is prepared for it. It's already galvanically decoupled. And we are investigating how to do fast control loops in a zonalized approach. So, what do I want you to carry away? The current trend within all our ecosystem call for simplification here in our projects, because the economical complexity we can't control. We have to handle it. Ethernet, although definitely increasing in importance, is not the answer to everything. But Ethernet can always be a good role model by providing base layer security, by providing scalability, by providing a multi-vendor market, and Ethernet has already proven this, by creating innovations over the last years, and everybody finds his place to create innovation. It's not a closed system where one company has to provide everything. Everybody can bring his best ideas to the table. Zonalization of data needs to be discussed. Do we need it? How do we do it? How do we do it with high speed? And we can only do it with a lightweight solution. Give you an idea, we are distributing power. That's the main benefit. Distributing power, meaning a lot of amps, and PCBs designed for this power. They are probably not the right PCBs to go with 50 gigabit or something like that to them. And standards help in reacting to exactly this fragmenting business model. Create the right standards, push for the right standards and not a fragmentation of standards, and do it together. So we have enough challenges, we as a whole industry. Let us work together to establish those fundamental elements. We drive to have a car running and being interesting and being fun to drive and working and being a business model for us in the future too. Thank you.
Thank you, Christoph. Any question?
Okay, that's short.
Clear?
Probably I stated clear.
No.
I'm Hoai from Volvo Cars. So my question is, I'm interested in this data collection, how to collect data and send it to the back end. What do you think about data-centric? I think a couple of years ago, Stellantis have also presentation saying that, okay, we are in the now service-oriented architecture, but we want to move more like a data-centric where you define property of the data and you want to get it to the cloud, for example.
So the first thing is I'm afraid I'm not an expert in AI and the data modeling for AI, but I can try to give you the answer. The idea is you have all the context knowledge available within the car. So, for example, if you put all the cameras to one side, have the navigation data and the map data on the exactly same side, you can aggregate this data and do functionalities which just work in the car, like, I don't know, follow the red car in front of me. You have to get the color, you have to get the car, you have to get navigation together, whatever. So you have to put this together in a car. And if you already know this sum of pixels in front of me is a red car, you're not sending data to the backend, this is a sum of pixels. You're sending just a data entry with this is a red car, using less bandwidth. And then you can, in your backend, I don't know, choose how often have you followed a red car? Are red cars diminishing? And should I give my customer the choice to buy his next car in red color?
Okay, maybe not so exact. I was thinking more for the communication, for example, DDS or some IP or what kind of communication protocols. But maybe
to get the data to the center, or to get the data from the
center
to the center or out of the center?
Out of the center.
Here I have to rely on my colleagues. I'm afraid I don't have anybody here.
Thank you.
Hello. I am Nicolas Morin from Stellantis. There is something I'm not sure I understood correctly. The drastic reduction of the amount of wire harnesses in your, there are 2 slides on that. Did you say that it was linked to the fact to the reduction of the power?
It was mainly by power, so the backwards is here, I guess. Let's try. Hope so.
Because it's drastic, so.
You're relying to...
Yeah, this one.
From here?
Yeah.
To here?
Here to there. Indeed,
it's mainly power. It's mainly power. So power and IOs. By zonalization of power, and as I stated, you don't have to put every cable running to a centralized fuse box.
Yeah.
You have several fuse boxes. And you're not running every I/O to somewhere in the center.
Yeah.
You collect them in the zones. That's the reduction of the wiring harness.
Okay,
it's
you
not.
collect them. Can we say it's linked to high speed? Like I can group things like with backbones or. What links?
Currently, the backbone within our Neue Klasse architecture is just an Ethernet connection going from the front to the rear.
Yeah.
And from there, it's still distributed IOs, CANs, whatever. But going from front to rear is just a twisted pair in power.
Oh, okay, I see. And I have a second question. I'm sorry, it's not exactly the point here, but you, in your slide showing the networks evolutions on the left, I think it's not this one. Next one. Next. Sorry. You know, next. Where is it? Yeah, this one. Yeah. Sorry, it's not the. I know it's not the target of all of us here, but you say 5 megs CAN is under bracket. Does it mean that you don't? Does it mean that you don't validate CAN SIG?
We are interested in CAN SIG. We are not interested in CAN XL. Since CAN XL is exactly between where you are with the CAN FD protocol.
That's right.
And with Ethernet. But we are interested in SIG, and we are prepared for 5 megabit use cases. We just have not had one yet.
Okay, so you are evaluating that, let's say.
Yeah, we already did.
Very good, thank you.
Michael Spetz, MO Semiconductor. So concerning the power architecture, you mentioned that you have one power zone.
No.
No?
No, it's not one power zone. In Neue Klasse, you have 4 power zones.
4 power zones.
You have the body controller combined with a zonal controller distributing power. You have a purely power distributor, power zone. You have the rear zone, and you have the roof zone.
Okay, then that was a misunderstanding by my side. Okay, that's what I would have expected. Yeah.
So if you buy one and want to look deeper into it, you miss the joy of driving it. You will find exactly this.
Okay, thank you.
Hi, Christoph. I'm George Kashishian. I'm with Corning. My question is about redundancy. Like, there's so much data nowadays on the cars and so many sensors. What do you have to say about what signals need to be redundant? How would you do that? How would you do that?
That's not a short question.
Okay.
So where do you need redundancy? Redundancy you mainly need if you have a fail operational system. And currently your redundancy for any system within the car, if you are not designing it with a flaw, is the driver. He has his own biomechanics, he can push a brake, he can handle a steering wheel, and he is able to look around. If you are not going into a fail operational system, redundancy is not that much of an issue. If you go into a fail operational system, a system like steer-by-wire, brake-by-wire, or more advanced ADAS components are, it's seldom a redundancy within the communication. That's mainly not the issue. So if you're losing power, and a lead-acid battery is a single failure cause, redundancy in your communication doesn't help. The idea we are investigating the most is, let's call it that way, having a driver and a co-driver, and both are capable to make the car stop. And both have their independent energy supply, both have their independent network, both have their independent actors, both have their independent sensors. It is, and that's why level 3 and level 4 is expensive. The difference is exactly from a level 2 plus system to a level 3 system, you need this redundancy, because if your sensor fails, you still have to have an idea what's happening around you. You need redundancy. If your brake system fails, you still have to have redundancy. You need to be capable of standing. If your steering system fails, you have to have redundancy. You still have to be capable to steer. And making the step from an always functioning level plus system to a basic level 3 system is mainly cost. The driving experience is more or less the same. Tesla 5 Series, you can drive hands off with 130 kilometers per hour, a little bit more. It's a level 2 plus system. If you're doing anything in level 3, you can still just ride hands off, because you have to be more or less aware, you can't be sleeping, and if you really want to get drunk and go home, take a taxi or take an Uber.
Thank you, Christoph.
Maybe one last question, because people will start feeling hungry after.
Thank you.
We have one more.
Okay. Thank you for the presentation. It's very interesting. I just captured a small detail for the in-house Ethernet stack. So at the beginning, you talk about the standardization, and in that slide, I saw AutoSAR, all of this. But now this in-house Ethernet stack.
I have to definitely rely to the Toyota presentation we heard in the morning. If you want to do fast control loops on Ethernet, and zonalization of fast control loops is only possible doing Ethernet, otherwise having gateways in between, it's not fast anymore. You also need to have a fast stack, and this stack has to be capable of doing other stuff than just managing itself and managing communication. So you're not doing it for the sole purpose of being there and communicate. And therefore, you are probably going into having something like a CDD, bypassing parts of the stack. And we already developed something like this. We already prototyped it. And I think my colleague Carl already had a presentation about this some years ago on AEC. So the idea here is really to not clutter the stack with parts you don't need for fast control loops. You bypass it for exactly these fast control loops, and all the multi-purpose you have in Ethernet, you do in another core.
Okay, great, thank you.
Okay, thank you, Christoph.